Krishna Rao. I'm Assistant Professor in CSE department. I'm handling compiler design for the 5th semester. So in the previous classes, we have discussed the regular expressions, finite automata, NFA, DFA, NFA with epsilon. Then we started discussing the interconversions between these regular expressions and finite automata. So we already in the last class we have discussed conversion of regular expressions to finite automata. Right? Now we'll discuss another conversion method, NFA to DFA. Right? So in this class we'll discuss how to convert given NFA to DFA. Right? Now here a problem is given and asked to convert A into respect to DFA. Now we'll take here is first a simple problem we'll take. Okay. Simply we are taking NFA for x01 y. This is NFA we are considering x01 y and convert to DFA. Right? Convert this NFA to DFA. Writing the NFA is very simple. Right? Writing NFA is very simple. Simply we consider initial state Q0 and the transitions for conditions, that is on 0 goes to Q1 and on 1 going to QF. So we have considered the transition for the condition having 0 1. Then what are the x and y? The x and y are a sequence of zeros and ones. So we are representing this as x and here 0 1 to represent y. So QF on 0 1 going to QF which represent y and Q0 on 0 1 going to Q0 which represent x. So we are constructed an NFA for the given problem. Now we want to convert this NFA to DFA. Now we'll see what is the transition table for this one. This is the NFA transition table. Right? We represent a columns with symbols, alphabet, rows with states. Right? A Q0 is the initial state, Q1 is another state, QF is a final state. Now Q0 on 0, what are the output states? Q0 comma Q1. Q0 on 0 is Q0 comma Q1. Then on 1, Q0 on 1 only Q0. Then Q1 on 0, Q1 on 0 5. Then Q1 on 1 QF. Then QF on 0 1 going to QF. QF on 0 going to QF. QF on 1 going to QF. Right? This is NFA, this is given. Now for this DFA, we have to write equivalent DFA. For this NFA, we have to construct an equivalent DFA. So we representing DFA with this one, right? This is NFA, right? This is the NFA transition table that is given. Now this NFA transition table we are converting to DFA, right? So here for the conversion of DFA, first thing we have to consider, this is a NFA. We are assuming that this is a NFA, right? File tuple notation, right? Initial state and final state. Now we have to convert to DFA. For the DFA, we consider M dash. Here, first step, Q dash will be the power set of Q. The states of DFA are the equivalent to power set of Q, right? Right? So we consider the power set of Q, right? So what are the Q states? The Q states are Q0, Q1 and QF. Then what is the power set of Q? Empty set, Q0, Q1 and QF, Q0, Q1, Q0, QF, then Q1, QF, then Q0, Q1, QF, right? Empty set, Q0, Q1, Q2, QF, then Q0, Q1, Q0, QF, then Q1, QF, then Q0, Q1, QF. This is a power set of Q. Here, how many states are there? 3 states in NFA. 2 power 3, 9 states. 2 power 3, 9 states will be in the DFA, right? Power set of Q. 2 power 3, 2 power 3, 8 states. In the DFA, 8 states are there. Finding the 8 states on alphabet 01 is a lengthy process, right? So here we have to write for all the states to its equivalent states, right? Here how many states are there? There are 8 states. For 8 states we have to find the transitions for zeros and 1, right? So which are going to results 16 transitions we have to find, right? So in lengthy procedure, write all the 8 states and write all the 16 transitions to make it complete procedure for the conversion of NFA to DFA, right? So we have to write all the state 1 to state 68. Each state on 0 on 1. Each state on 0 on 1. So we have to find 16 transitions. That is a lengthy procedure. So another way, we consider only the transitions which are actually in NFA, right? So in NFA, what is NFA? Q0 on 0 going to state a state Q0, Q1. To make it a DFA transition, we are considering this as DFA transition function. Q0 is a DFA state on 0 going to square bracket of Q0, Q1 is going to square bracket of Q0 and Q1, right? Square bracket of Q0, Q1. Now, Q0 on 1 is Q0. It's equivalent NFA transition. Q0 on 1. Q. Right? We are ready. Q0 already considered. So what is the new state we have? Q0 and Q1. Our new state is Q naught, Q1 on 0 we find. For that purpose, we consider NFA transition Q naught on 0 union with Q1 on 0. Q naught on 0, Q1 on 0, which results Q naught, Q1, which resulting single state of Q naught, Q1. A single state of Q naught and Q1. Then, same on 1. Single state Q naught, Q1 on 1, which results Q naught on 0 on 1. We are considering the NF phase Q naught on 1 union with Q1 on 1, which results to Q naught, QF, which results to Q naught and QF. Q naught, Q1 already considered. Now consider the new state Q naught and QF. Q naught, QF on 0, which leads to Q naught on 0 union with QF on 0, which results to Q naught, Q1, QF. Then, similarly, Q naught, QF on 1, which results to transition function of Q naught on 1 union with QF on 1, which results to Q naught and QF. Right? So simply we are writing here Q naught, Q1, QF. Here we are writing Q naught, QF. Right? We are writing Q naught, comma, QF. Now, add this new state Q naught, Q1, QF. Right? So, here DF is Q naught, Q1, QF on 0. On 0. Right? Which is just Q naught on 0. NF is Q1 on 0. NF is QF on 0. Which resulting simply Q naught, Q1, QF. Similarly, Q naught, Q1, QF on 1. So, Q naught on 0 on 1, Q1 on 1, union with QF on 1, which resulting Q naught, QF. So, we are getting once again Q naught, Q1, QF. Here Q naught, QF. Here any new more states are there? No. Q naught, QF also we found. Q naught, Q1, QF also we have found. There are no more new states. So the completion of NFA is completed. Right? The completion of the NFA to DFA is completed. Which are the final states? Right? Here this QF is there. So it is a final state. Here it is a QF is there. So it is a final state. So wherever in state QF present, the state is considered as a final state. Since here it is a QF, is a final state. Here it is a QF, it is a final state. So we are converted the NFA to DFA. Now we'll see it's a transition diagram. So consider Q naught and Q1. Right? Then Q naught, QF, then Q naught QF, then Q naught Q1 QF, right? So we are considering the states, right? So here this is a final state, here it is a final state. Q naught on 0 going to same state, right? On 1 going to same state, on 0 Q naught Q1, here on 0 same state, right? On 1 it is going to Q naught QF, Q naught Q1 on 0 is going to Q naught Q1 QF, on 1 same state, then Q naught Q1 QF on 0 is the same state, on 1 going to Q naught QF. So we are represented the equivalent DFA in the transition diagram. This is the complete process of the conversion of NFA to DFA. Here, so finally we found 8 transitions. There are 4 states which are connected to initial state. The initial state Q naught is connected to only through 4 states, right? So we are considering only the 4 states and its respective transitions of 8 transitions. Instead of 16 transitions, now we are considered only the 8 transitions for the completion of conversion of NFA to DFA. So here, now we'll take this one. In this problem, there are 4 states. These 4 states means what is a 2 power 4? 16 states. So in DFA, there is a possibility of 16 states. Then total transitions, 32 transitions, right? So in NFA, there are 4 states, which equivalent to DFA, it may be maximum of 2 power 4, 16 states. Then we need to find all the 32 transitions. So instead of finding all the 32 transitions, we are considering only the states which are connected to initial state. So here, this Q naught on 0 going to Q naught Q5. So we are considering this transition in DFA, right? Now this Q naught on 1 going to Q naught Q6. So we are considering the state Q naught Q6. What are the 2 new states we are considering here? Q naught Q5. This new state here Q naught Q6. Now we are finding the transitions of Q naught Q5 on 0. Now Q naught Q5 on 0 is Q naught Q5 QF. On 1 is giving Q naught Q6. Now this is a new state. So consider this new state here. So Q naught Q5 QF we are considering new state to find its transitions. Now here Q naught and Q6. Here Q naught and Q6 on 0 is giving Q naught Q5 and empty set. So simply we are writing Q naught Q5. Then Q naught Q5 on 1 giving Q naught Q6 QF, which is resulting Q naught Q6 QF, that is a new state. So we are considering the new state here. Right. Now Q naught Q5 QF on 0 giving Q naught Q5 QF, on 1 is giving Q naught Q6 QF, right? Any new state there? No. So already we are considering. Now Q naught Q6 QF on 0, Q naught Q6 QF on 0, Q naught Q5 QF on 1, right? On 1. So Q naught Q6 QF. So here in the 16 states, only the 5 states which are connected with the initial state. Q0 state, Q0 Q5, Q0 Q6, Q0 Q5 QF, Q0 Q6 QF. So we consider these 5 states transitions on 0 and 1, which in the conversion of NFA to DFA. Right? So instead of finding all the 32 transitions, we are considering only the initial state and its transitions and which are connected to initial state. So which results to only these 5 states are connected with our initial state. Then which are the final states? Here in NFA, QF is a final state. So in this both the states QF existing. So this both the states of DFA are considered as the final state. Right? So this is a transition diagram for DFA which is equivalent to given NFA. So this is a Q0 state on 01 going to Q0 Q5, Q0 Q6. On its transitions is going to Q0 Q5 QF, Q0 Q6 QF. Right? So this is a transition diagram for the DFA which is equivalent to given NFA. Right? So with this I am closing this section, the conversion of NFA to DFA with these examples. So in the next class we'll continue with another topics. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.